Deploying large structures in space is one of the most difficult things NASA does.
The antenna, the computer, the thrusters, all of those things have been used before, but when you put them together in this system with this large rotating antenna, what you get is a pattern that covers the entire planet, and with that comes some engineering challenges.
What we need to do is develop an antenna that's very small before we launch it, and then it blooms out to a much larger antenna on orbit. That's one of the big challenges for SMAP.
There's a 20-foot antenna at the top of the spacecraft. When you look at how that system works, this large umbrella-like looking thing collapses down just like an umbrella would, folds at the elbow, and then folds again back along the side of the spacecraft. Packaging that bit of technical origami is a real trick.
We need to test the antenna on the ground like it will be deployed in space. But the antenna was designed to operate in zero gravity, which makes testing on the ground quite challenging. We can't just simply deploy it on the ground and then spin it up. So what we have to do is test the whole system in pieces.
First, we look at what it takes to sort of balance the spacecraft. Then we look at how that whole system behaves together when you spin it.
We test the reflector extensively by itself. We test the boom that deploys it by itself. We also have a very challenging thermal environment on orbit. It can see 100 to 200 degrees variation in temperature.
We take the data that comes from each one of those little tests and we put it into the model to describe the end-to-end behavior of the system.
Testing and testing and testing, and we test a little more until we're convinced that we've tested all the different environments and met all the requirements of the system.
We considered every scenario from science and engineering, physics that we could imagine. It's human nature that you always would like to do more, to be more convinced. But there's a fine line between testing too much and breaking something and testing enough and convincing yourself it's good.
We've gone through at least 10 to 12 deployments just while it's been here. And most of them have been successful. A few of them we've had problems with, and we work with the team to figure out what the problem is and resolve it. And then we've had 3 successful deployments right before we shipped it, and they were all picture perfect.
This is probably one of the greatest accomplishments of any of our lives. It's not often you get to be part of a mission that has a global impact. You know, as children, we all imagine someday being able to do something that'll change the world or somehow being heroic, and being able to contribute to the strength, to the health of the planet and to the human race is incredibly powerful.